All right, we're going to take a look at 31. Antonio buys 4 notebooks for $3.50 each at a store. The next day he returns to the store and exchanges the notebooks for 3 notebooks that have gone on sale for $1.75. Antonio uses the following expression to calculate the amount of money he should receive back from the exchange. Which of the following expressions could Antonio also have used? So they give you an expression. The most critical piece here is that you think about how you could rearrange or express this differently. So they're asking for an equivalence. In this case, the equivalence could be because this is the same information as the way it's represented in the problem above. So notice, right, here is the difference in cost, right, for 3 notebooks. So 350 minus 175 times 3, plus the additional 4th notebook that was worth $3.50. The other expressions aren't going to work for a couple of reasons. A isn't going to work because it doesn't account for the number of notebooks. C doesn't work because it only accounts for the number of notebooks that are valued at $3.50, but it excludes the number of notebooks for $1.75. D doesn't work because in this case, you need to relate the number of notebooks to the cost of the notebooks. So multiplying the numbers by each other isn't going to help you solve that problem. And E has the same dilemma. So essentially 12 notebooks minus the cost isn't going to get you to the information that you need. So this is the only answer, B, that is an equivalent expression to the expression for 31. Let's do this for 32. Rudy needs to calculate 14% of 50. He does so by computing it in the following way. 50 times 14 out of 100. Which of the following methods could Rudy also use to determine the correct percentage? Well, here it's important that we remember that 14 out of 100 is the same thing as 0.14. So we could also do 50 times 0.14, and that would be the correct answer, E. If we look at the reasons why A is incorrect, right? When we're thinking about this setup, it always has to be relative to the percent value, so it's always relative to 100. So I can't divide by 100 minus 50. That's not going to get me where I need to go. Same thing for B, right? I can't just divide 50 by 14 because it actually has to be the percent relationship that I'm looking for. C won't work because it's actually mixing up these two terms, and they're not interchangeable. And then D won't work because I'm dividing at top, and that's not the correct setup. So that's not a representation of this expression. So A through D are all options that aren't going to work for me. Okay. Take a moment, reflect on your learning while I erase.
Will you erase 32?
Yeah.
Can you go ahead and just solve 50 times 0.14?
Oh, for sure.
So just see the number of what 14%.
Yeah, absolutely. So if we think about it,
Oh, it's going to be 7.
yep.
Okay, I didn't move my decimal place, that's what threw me off.
Yep.
Okay. These equivalence questions are getting.
I know, right? It's annoying. But does that make sense?
Yeah, I
Okay.
didn't move my decimal place.
Okay, no worries. That's part of the value of this is as a practice session, it helps you find your errors, which is a really important point. It's probably worth talking about this. Folks all the time, I'll answer your question in just a minute, always ask me, hey, what's the best way to review for the CBEST? And the answer that I give every time is it's practice problems. It's solving a problem until you find your most common source of error. And you're not alone. I make errors all the time. The goal when you're prepping for the CBEST is to recognize the error that you're most likely to make and then be able to catch that error and fix it, right? It's not the expectation of perfection. That would be an unreasonable expectation. But it's helping you to figure out where am I most likely to make errors, because if you can figure out that, then every time your students are stuck, you have a pretty decent sense of where they might be stuck and how you can help them. So anytime you're struggling with a problem, just remember that your persistence in terms of figuring out how to solve that problem likely will translate directly into your ability to help students who would also be struggling with that problem. Okay, I had a question before we move on. Yeah?
Yeah, for both of those, so like something that I'm learning I clearly struggle with,
Yep.
equivalent fractions, could you solve the one that they give you and then solve the other one?
You absolutely could.
To see what-
Yep.
Okay.
So you're going to laugh at this, but sometimes, right, you know, you're like stressed in a testing environment and your brain just stops working. Hey, I have that moment where it's like a gasp and I'm like, wait, I know how to solve this. I know how to solve this. And you get stuck. Well, one of the easiest things you can do is take what you know how to do, solve the problem, and then worst case scenario, plug it in and check your answer. That's always a great way to be able to check. The only challenge there is that it's going to cost you some time. So that's part of the reason why we want to be strategic, move really quickly through the ones we're confident in, answer them, so that we can buy a little bit more time if we get one we're stuck on and we need to go back and fix. Okay, 33. The table shows Sabra's grades for a class. For her overall average, the test average counts twice as much as the quiz average. And the final exam counts twice as much as the test average. To find her overall average, Sabra uses the following expression. Which of the following is another way to find her overall average? So all it's going to ask you to do here is do some grouping. So all we're doing here is grouping. So this is the same as 2 times 79. This is the same as 4 times 88. And 83 is by itself. So in this case, I'm looking for, right, something that's similar to dividing by 7. Well, in this case, I know that dividing by 7 is the same thing as multiplying by 1 over 7. That's an equivalent expression. So the answer is E. Let's take a look at the other answers, though, and figure out why they don't make sense. So A doesn't work because I still have to divide 83 by 7, right? I can't exclude that. I have to include 83 divided by 7. So that's why A doesn't work. B doesn't work, right? Because of the same problem, right? I'm not dividing by, right, 7 for all of my components. C doesn't work because in this case, right, 0.7 is not the same thing as dividing by 7. So I have to see that really carefully in order to catch that mistake. And then D doesn't work because dividing by 1/7, right, is the opposite of dividing by 7. Right? Dividing by 1/7 is the same thing as multiplying by 7. So that's why D doesn't work. But it's tricky. You really want to make sure that you're clear. So these are equivalent expressions. Just like multiplying by 7, right, would be the same thing as dividing by right? 1/7. So those are equivalent expressions. So if you get stuck, it's useful to be able to think about that. Okay. Let's take a look at 34. Use the chart below to answer the question that follows. The chart above displays a relationship between values of x and y. Given this relationship, what would be the value of y that is missing? So let's think about our relationship. We're looking for patterns here. 1, 1.5, 2, 2.5, 3, 3.5. Here, right, 3, 4.5, 6, missing value, 9, 10.5. So what's the relationship, do you think, between x and y?
Times 3.
Times 3. Times 3 how? What am I multiplying by 3? X times 3, right? So if I do this times 3, that equals 3. This times 3 equals 4.5. This times 3 equals 6. So then this times 3 would be 7.5. Now, if, right, you have that moment where you're like, my brain's just not working, I'm panicking. You can look at the pattern. These are whole numbers, right? Those have to have a 0.5. And if you're thinking 3, 6, 9, right, then you can estimate what's a number between 4 and 10 that would get you to an answer. That's another way that you can do it if you're like, I'm not sure, I'm rattled. Okay, take a moment, reflect on your learning.
So the answer for the 33 is wait.
Yep. That is correct. Okay.
I don't know how to say like if I multiplied or something.
Okay. A school district is proposing a 5% increase in the number of days in a school year. Currently, there are 180 days in the school year. How long would a school year be with the proposed increase? So they want a 5% increase. So 5 out of 100. Right? Now, here's one way that you can solve this problem. Right? If you're thinking about, right, cross multiplying, that's one approach. So 180 times 5. Right? So 900 equals 100x. So I divide both sides by 100. So x is going to equal 9. But remember, they want the total, so it's 180 plus 9, which gives me my total new increase, or 189 days. Now, you could probably estimate this using a different approach. You could say, well, what's 10% of 180? So 10% of 180 would be 18. 5% is half of 10%. So if I divided 18 by 2, that would also get me to 9. So that's another way that you can do it. Okay, Questions? Questions for 35? All right, let's do 36. Which of the following mathematical statements is correct? Oh, these are always a great example of how you can simplify your thinking, right? So, let's just think about size and relative scale. So I have 3 2/3 less than 3 1/3. Is that correct? Nope. Right? So I know right away A is a no-go. Right? Because 3 2/3 is bigger than 3 1/3. Right? So this sign is wrong. Let's take a look at B. 3 2/3 greater than 2 2/3. Yeah, that's true. Okay, we're all right. But is that greater than 3 1/3? Is that true? Nope. So I know that one's not correct. Let's take a look at C. 3 1/3 is greater than 2 2/3, which is greater than 3 2/3. Is that correct? Can 3 be less than 2? Nope. Let's take a look at D. 3 2/3 greater than 3 1/3, greater than 2 2/3. Oh, thank goodness. Whew, that was a long one. And of course, you could go through and check E just to be sure, right? Because if you're like me, sometimes you worry. And that's true. 3 1/3 is less than 3 2/3, but 3 2/3 is definitely not less than 2 2/3. So really what this is checking is, do you understand the value of less than, greater than, when the number that you're comparing, right, is on this side. Okay, let's take a look at 37. Use the mathematical statement below to answer the question that follows. So we have 2/6 So here's the challenge. These two, right, don't have a common denominator. I can simplify them, right? I could simplify this to 1/3. And I could simplify this to 2/3. Right? Yeah. 3/4. Thank you. Phew, brain. Right? Human, everyone makes mistakes. Know your errors, right? The pause is my brain being like, no, 2/3 is not it. You're wrong. Find another answer. All right, so 1/3 and 3/4. So I'm looking for something that is between those two numbers. Well, I know that it's not 1/4, because 1/4 is less than 1/3, so I can ignore A. What about B? 1/3. Well, the fact that there is not a less than or equal sign means that I can't use B. What about C? Is 1/2 between those two? Yes. Oh, thank goodness. What about D? 3/4 won't work for the same reason that 1/3 didn't work. Right? I have to have a greater than or equal sign if that would be the answer. And then E, 9/10 won't work because it's too big. It's too big to meet the criteria. Okay. Take a minute and reflect on your learning. Think about a plus and a minus. What made sense? What might need a little bit more work? I often have students tell me, well, what if I'm like almost there but not quite? Then put it as a minus. You can always go back and review it later. Okay, here we go. Let's take a look at 38. So which of the following mathematical expressions is equivalent to BH divided by 2? Well, let's take a look at our options. So A has B over 2 times H over 2, which would be the same thing as BH over 4. So that's not an option. Let's take a look at B. 2 times B times H. Well, that's the same thing as 2BH. So that's not an option. Let's take a look at C. B over 2 plus H over 2. Well, I can't actually combine those, right? Other than saying just as it is. So that's not really an option for me either. D. 1/2 times B times H. That is the same thing as BH over 2. So D is my option. E. B times 2H is the same thing as 2BH, which is that guy, so I know that's no go either. So 38, the answer is D. Let's take a look at 39. Which of the following numbers is between 2,329,500 and 2,598,100? So here's where this is a useful trick. My 2's are the same, I don't worry about that. Here, my 0's are the same, so I don't worry about that. So I'm looking for a number that's between 3 and 5. Let's see if we have that. So I can get rid of A, because it's not between 3 and 5. I can get rid of B, and I can get rid of C, maybe, and D, maybe. So I'll come back and do a comparison. So 329, right, I can get rid of B. 329, I can get rid of C, because 327 is smaller than 329, which leaves me with D and E. So 329, 500, right? So 329, 333, I can also ignore because that's smaller because of the 5 position. So that means the only option that's left to me is E, 2,589,200.
But that's greater than the 2,000 in the A.
No, because this is 598.
Right, 100.
Uh-huh.
And that one is greater than 598.
Oh, but it's not. Take a look.
But
This is 589,200. Right? So it comes here.
oh, okay, sorry.
Oh, no. It's a great question, right? Because it's super easy to get misled. Right? So you're right. You're comparing and you're saying, okay, is 589 less than 598? Yes. Right? And you're worried about this 200. But you have to keep in mind, as long as it's less than 598, it doesn't matter what that 2 number is. Great question. That's a great clarification. Okay.
Oh, I'm sorry I was gone.
That's all right.
I was
You're fine.
hungry,
No worries. Take care of yourself first.
Thanks.
You cannot take care of others unless you can take care of yourself first. All right.
Wait up, I'm not done.
I will happily wait. So take a minute and reflect on your learning. Okay. Let's take a look at 40. If the value of x is between 0.051 and 0.038, which of the following could be x? So let's take a look. I have 0.0051 and I have 0.038. So which are the ones that I can exclude? Right? Notice I have 2 zeros here, right? And I only have 1 0 here. So which are the terms that I can exclude? Well, I can exclude 0.0042 because that comes before 0.0051. And I can exclude 0.049 because that comes after 0.0038. So this is A, this is C. I can exclude 0.052, that's D, and I can exclude 0.06, that's E, which means the only option that I'm left with is 0.0261. So that one, which is B, is correct.
Will you